Good day, everyone. This is exercise 10, chapter 2, properties of pure substances. So we have a sealed rigid vessel who has a volume of 1 meter cube and 2 kilograms of water at 100 degrees Celsius. What is the pressure when the temperature is 200 degrees Celsius? So here we have two states. The first state, we have a temperature of 100 degrees Celsius. We have a pressure 1, and we have a mass, and we have a volume, so we can work out a specific volume which can be calculated as volume over mass, 1 meter cube divided by the 2 kilograms. So having the two independent intensive properties, both the temperature and the specific volume, are enough for us to define the state of the system. That's according to the thermodynamic principles. So the temperature and the specific volume are two independent intensive properties. However, temperature and pressure are sometimes independent, not always the case. And that's dependent whether the system is undergoing a phase change or not. If you wish to find the pressure 1, then perhaps we could look at table B11. So at a temperature of 100, you will find that the specific volume calculated just now of 0.5 lies between the fluidic specific volume and the vapor specific volume. This means we are undergoing a phase change. So the pressure in this case will be the saturated pressure, 101.3 kilopascal. To explain this further, let's draw quick the dome shape. This is your temperature, this is specific volume. So at 100 degrees Celsius, since our specific volume somehow lies between these values, this means the pressure, constant pressure line, is corresponding to the saturated pressure line, which is the 101.3 kilopascal. Although the question did not ask us to calculate P1, we are just doing this for as a sake of completion. So now state number 2, temperature is 200 degrees Celsius, and we need to find the pressure. As mentioned before, the state of a simple compressible system is completely specified by two independent intensive properties. One property is temperature. This is given. Now the second property is not given, and we need to find it. However, the question is clearly saying that the container or the vessel is sealed, means it's a constant mass, no mass coming in, no mass leaving the system, and also it's rigid, so the volume is constant as well. This means that the specific volume, defined as volume over mass, is also constant between the two states. Hence, in this case, specific volume 2 equals to specific volume 1. So now we have the two intensive independent properties, the specific volume and the temperature. Now we will be able to find our state, and then we can calculate or find our pressure value. So looking at the same table, B11, you will find that at temperature 200, the 0.5 meter cube per kilogram previously calculated lies between the actually is greater than the vapor specific volume, and that means we are in the superheated region. So at 200 degrees Celsius, our specific volume is bigger than the vapor specific volume. According to the table we just saw, this value is 0.12736. So our specific volume calculated at state 2 is greater than the specific volume phi sub g. So the first state is the temperature, so we are at 200 degrees Celsius, and the second property shows that we are on the right hand side of the dome, so we are somewhere here. That means we are in the superheated region. So this means we need to go to table B13. So we need to look at a temperature of 200 degrees Celsius that has a value of 0.5. So what we find is that at 200 degrees Celsius, at pressure of 400 kilopascal, the specific volume is 0.53, which is slightly greater than our calculated value. If we scroll down, at 500 kilopascal and at 200 degrees Celsius, we have a specific volume of 0.42492, which is slightly lower than our value of 0.5. So now we can interpolate because these two values bounds our range. So from table, we will interpolate between 400 kilopascal and 500 kilopascal. So this is our pressure that we need to find, and at 500 kilopascal, now our value is 0.5. So by interpolation, doing the calculations, the value will be 431.3 kilopascal. Is a pressure of 431 expected? Well, yes, we are expecting a higher pressure because we have a sealed rigid vessel that's been heated from a temperature of 100 to a value of 200. So we doubled the temperature, and if you notice the pressure, it went up by a factor of more than 4 in this case.